Welcome, Class 10 students. Today, we're diving into Chapter 3 of Science, Metals and Nonmetals. Specifically, we'll explore how metals and nonmetals react with each other, focusing on electron transfer and the formation of ionic compounds. First, let's understand that metals have a tendency to lose electrons from their outermost shell. When they lose electrons, they become positively charged ions, also known as cations. On the other hand, nonmetals tend to gain electrons to complete their outermost shell. When they gain electrons, they become negatively charged ions, called anions. Let's look at an example to clarify this concept: the reaction between sodium, a metal, and chlorine, a nonmetal. Sodium, Na, has one electron in its outermost shell. Chlorine, Cl, needs one electron to complete its outermost shell. So sodium readily loses its one electron to chlorine. This transfer results in sodium becoming a positive ion, Na+, and chlorine becoming a negative ion, Cl. These oppositely charged ions then attract each other, forming sodium chloride or sodium chloride. Another important example involves magnesium, Mg, and chlorine, Cl. Magnesium has two electrons in its outermost shell. It loses both these electrons to two separate chlorine atoms, as each chlorine atom can only accept one electron. This forms magnesium chloride, or magnesium chloride. This beautifully illustrates how a metal can transfer multiple electrons to nonmetals to achieve stable electronic configurations. The compounds formed by this complete transfer of electrons from a metal to a nonmetal are called ionic compounds. The force of attraction between the positively and negatively charged ions forms an ionic bond, which is a very strong electrostatic force. You might also hear ionic compounds referred to as electrovalent compounds, as their formation involves the transfer of valency electrons. Now, let's quickly go over the key properties of these ionic compounds. Firstly, ionic compounds are generally hard solids. This is due to the strong electrostatic forces of attraction between the ions. Consequently, they have high melting and boiling points, requiring a lot of energy to break these strong bonds. Secondly, most ionic compounds are soluble in water but are insoluble in organic solvents like kerosene or petrol. Water's polar nature helps in dissociating the ions. Thirdly, ionic compounds conduct electricity in their molten state, or in an aqueous solution. In these states, the ions are free to move and carry charge. However, they do not conduct electricity in the solid state because the ions are rigidly held in their crystal lattice and cannot move freely. In summary, understanding how metals and nonmetals react by transferring electrons is crucial. This electron transfer leads to the formation of ionic compounds, which possess distinct properties due to the strong ionic bonds. These concepts are fundamental and frequently tested in your Class 10 science exams. Make sure to review them thoroughly.